All right, good morning, everybody. My name is Jesus Rodriguez. I'm the product manager for in-channel screens here at Parkson, and just going to do a little training this morning on in-channel screening products. This is a little bit more advanced, perhaps, than a general introduction, so let's see what we're going to talk to you about today. I'm going to talk to you really about what is a screen, why it's important to screen. We'll cover the Parkson in-channel screening products, features and benefits, and I'll talk to you a little bit about channel basics, what you need to know, the information that you need to have in order to size a screen for a customer. And then I'll tell you about the new AquaGuard Ultra Clean. And with time permitting, we'll get to the washing and dewatering products as well. So what is a screen? When you mention the word screen, a lot of different things come to mind to people. But generally, you don't think of a screen as an AquaGuard. And that it's used in wastewater treatment to filter our waste. But generally speaking, when we talk about wastewater screens, a screen is a physical barrier. So what we're trying to do is separate solids from liquids. And a screen will have a defined opening so that any solids larger than that opening are filtered out and things smaller than that opening will pass through. Now, in a wastewater screening market, we talk about different categories, coarse screens versus fine screens. So coarser screens have larger openings from 3/8 to 3 inches, and fine screens are generally categorized as 1/4 inch openings or less. And in the marketplace today, the trend is to finer and finer, or smaller and smaller screen openings all the time. So customers want to filter out more and more solids because downstream processes are becoming more sensitive to trash. The second major category as it relates to screens is manual versus automatic or self-cleaning screens. Really, we don't talk about that much about manual screening anymore, except as bypass or backup to an AquaGuard or a automatic screen. Now, the goal of screening, as I mentioned earlier, is really to remove undesirable solids. When the customer can remove those solids, the benefits to his process really is to lower BOD and improve those downstream processes by requiring him to do less maintenance on that equipment because it's not being fouled by solids. So when we talk about undesirable solids in a wastewater stream, what are we talking about? Baby wipes are a big problem these days. Cigarette butts, plastics, straws, anything that can go into a toilet, ends up on the screen, and we want to take those things out. So here is another shot of an undesirable solid. You can see there that's a condom that has gotten lodged in the weir of a clarifier. So as long as if he stays over on the left side of the weir, he might end up in the sludge. And it might end up then being shipped out, dried, and end up on a farmer's field somewhere. So he doesn't want that. If it goes over the weir, it might end up in the clarified water, could end up fouling a pump, or in a lake or a stream, and you don't want that either. So we want to screen it out before it enters the plant. When you have a proper screening system, then there are many benefits to the wastewater treatment plant, municipalities in general. Proper screening helps to reduce energy consumption. If your water is clean and clear, less pumping's required. If your water is clean and clear, reduces maintenance. Again, you don't have to run around the plant unclogging pumps, cleaning out clarifiers, and things like that. And when you have proper screening and those solids aren't entering into the final product, the sludge, it reduces handling cost. And all that really means money for the customer. Now, one more time, protecting downstream equipment is really one of our main goals. And here's a shot. This is a down tube of an aeration system. And that stuff floating around the down tube really it's called rags. All right, so that stuff did not get through the screen in that form. These rags tend to be constituted of small fibers, hair, things that get through the screen and then reweave and form these large masses. So here's the shot again. This is a rag that was removed from a pump. And so that didn't come through the screen in that form. This is just small fibers that reweave and then constitute themselves downstream later on in foul equipment. So we want to get that stuff out. And then one more time, here is a shot of a similar aeration basin that was taken down for maintenance. And you can see how the aeration tubes are covered in those rags. Now, when we talked about energy consumption before, here's a perfect example. How efficient do you think that aeration system was covered in all of those rags? It wasn't. So the municipality was spending a lot of extra effort to aerate their process because their aeration system was no longer functioning efficiently. So that's the importance of screening and why we screen. So now let's get to the meat of the matter. I'm going to talk to you about, first, Parkson's AquaGuard. Parkson has been manufacturing and selling the AquaGuard since the late 70s. It's been a very, very successful, good product for Parkson. Got more than 3,000 units in the field. Of those, probably 500 or more are of the heavy-duty S type. And the reason why it's been so successful is because it is a very dependable, heavy-duty product that we continue to sell today very successfully. It is a primary screen. It's a headwork screen. Provides fine screening. Primary application is in sewage, wastewater treatment, but we also use it in drinking water applications, storm water, pump stations. Wherever solids need to be removed and water's running in a channel, the AquaGuard can be utilized. Why has it been such a good product? Again, it's very tough. It's proven itself. Typically, an AquaGuard that's well installed, sized properly, can be in service for 20 years. Now, it does provide a combination of coarse and fine screening, and I'll explain that to you as we go through the presentation based on how the elements are constructed. It is normally installed in open wastewater channels. However, it can also be installed in wet wells as well. The best way to see how an AquaGuard works is to show you a little video. Now, here you're seeing one AquaGuard element. The way that we fabricate the belt is we'll string those elements together on horizontal shafts, and then we'll string a series of these shafts together to make a continuous belt. Now, when that belt is introduced into the flow, this is the way an example of some of the solids that are removed. And you can see the coarse screening on the face, fine screening on the back. It's a little bit gooey. So when you have that continuous belt finished, here's a side elevation of the machine to the configuration of the AquaGuard. Now, the continuous belt there is lowered into the incoming stream. Water would be flowing from your left to your right into the plant. Now, as the water starts to flow, that trash begins to build up on the face of the screen, and the water level rises in front of the screen as that mat builds up and the screen is blinded. Now, when that water level reaches a preset limit, then the screen will index, lifting the trash out of the channel and then presenting a clean screen once again to the incoming flow. And that cycle will be repeated over and over until the undesirable solids are lifted completely out of the channel into the head of the machine for discharge. So there's a look at the trash being lifted up the front of the screen and into the head for discharge. So as those solids come up the front of the screen, then they're released at the back. If you're a heavy solid, you'll be released right there by gravity. If you're a sticky solid, then you might stick onto the face of the screen, and there is also an automatic brush that will then remove those solids that are not falling off by gravity. So to cover features and benefits for the AquaGuard, it is mechanically self-cleaning, so it doesn't need a lot of attention. They are delivered fully assembled, and some of these screens can get quite large, and we'll see a picture of that shortly. The AquaGuard does not have any moving parts under the waterline, so there are no submerged bearings or sprockets. And it has a very high contact area, and what that does is, by virtue of the way the elements are fabricated, it allows the screen to build up a very good mat and to get very, very fine screening as a result. Now, this is a very low power consumption machine. Even the largest screens are normally less than 2 horsepower. And screens also pivot out of the channel for maintenance. And the AquaGuard, the Model S, can be manufactured for flows up to 100 million gallons per day in a single unit. And finally, there are no physical attachments to the channel, so it's very easy to install. And when maintenance is required, there's no deattachment that's required to get the screen out. So here's a look at the bottom, the toe of the screen. We said there's no submerged bearings or sprockets. Instead, we have this turnaround rail that can be replaced. It's a wear item. Sprockets and shafts are typically all wetted parts are fabricated in stainless steel. We try to use the largest possible diameter sprockets that we can. In our large units, the S units, the sprockets also come with wear strips in between the teeth that can be replaced. So it's a maintenance item. On the smaller screens, the MNs, that does not exist. So the AquaGuard does come in 2 models. The MN is our standard size. The Model S is our heavy duty. And typical differences between the two, the MN has a 4-inch pitch chain, smaller elements. The S is an 8-inch pitch chain, larger elements. But we do offer the same spacings from 1 millimeter to 15 millimeter for the MN, but we do go up to 30 millimeter spacing for the S. And they are both installed in 60, 75, or 85 degree angles of attack for both. We have 2 frame styles. The A frame is the pivoting style. The T frame is the fixed. So here's a look at the differences, the physical differences between the MN and S elements. Again, the MN, the standard duty screen, is 4-inch pitch chain. The S is 8-inch pitch, much larger, much more heavy duty for larger flows. So before I told you about the coarse and fine screening capability of the AquaGuard, what I mean by that, remember you saw the face of the belt, what it looks like. So here's a look dead ahead. When the elements are run together, there's a spacing, a large spacing on the first face and a small spacing on the second face of the screen. So you get that coarse screening on the front face. The fine screening occurs on the back side. And what that does is it allows for large items to be caught up first, and then a mat builds up. So you start screening smaller and smaller items. So if you have a 6 millimeter screen, eventually you will start to screen out things much smaller than 6 millimeters if you allow that mat to build up sufficiently. So the element design really allows the AquaGuard to perform well beyond the capability of perhaps just a 6 millimeter opening. And those elements really allow the AquaGuard to carry. It has a very large carrying capacity. Along with the MN and the S, again, we talked about the difference in pitch. angles of installation. Discharge heights, again, I said the MN screens up to 40 feet, S-style up to 70. Openings that are offered 1 to 15 millimeters for the MN, up to 30 for the S. Horsepower requirements. Now, if we add that third line for the PF, which we'll talk about momentarily, that's also an AquaGuard with perforated plate media. It uses the S-style chain, 200 millimeter, also comes in the same angles of installation, up to 50 feet in height. 2, 3, and 6 millimeter perforated openings are available. Now, head loss requirements. When we design an AquaGuard screen for a customer, we like to keep the maximum head loss below 24 inches for an MN screen, below 36 inches for an S screen, and also below 36 inches for a perforated plate screen. Now that is the maximum that we like. So we try to design the channels to allow the customer to stay within that range. The units can handle more, and especially in these days we see a lot of specifications where engineers are asking us to be able to withstand an 8-foot head differential. And we can do it. We are doing it. It's very hard to test, but we know that the AquaGuards can handle it. For 8 foot, it has to be an S. An MN screen we will not provide with an 8-foot differential. So let's talk about AquaGuard cleaning. Really, the AquaGuard has 3 modes of cleaning. That first mode, when I showed you how the trash comes over the head of the screen, if you're a heavy solid, a ping pong ball, or a golf ball, you'll fall off by gravity. Okay? However, the primary mode of cleaning is this interaction between the elements. They're self-cleaning. So that movement back and forth between the elements is what really lets them release the solids. The third mode is that brush that I talked to you about, and we'll see it shortly. So here is a look from the rear into an AquaGuard. So this is the top turnaround of the screen. This is where solids will fall off if you're a large solid. If you're a sticky solid and you continue in, then you'll be hit by the brush. And that brush does the final cleaning of the belt. Earlier we saw how that belt is constructed, and it's constructed in such a way that it can be easily worked on in the field. One of the nice features of the AquaGuard is that if a customer has a 6 millimeter screen and they decide that they want to go to a smaller screen opening, we can do that for them in the field. So the screen can be disassembled, the smaller elements can be installed, and the customer can get more effective screening. So here are just some photos showing AquaGuards installed. These are MN screens. Now I always tell people, it says, well, Jesus, how do you know? He says it's kind of easy to know if you're looking at an MN or an S screen. If you look at the main drive motor on an MN is on the side of the machine. If you see the main drive motor on the roof, that's an S screen. But these are double wide, which we hadn't talked about yet. When double wide, what we mean by that is that there's 2 belts side by side in the same screen. So an MN will be single wide, only 1 belt, up to 3 feet. Wider than 3 feet on an MN, 3.5 feet and wider, will be double wide. For an S, up to 4 feet will be single wide. Wider than 4 feet will be double wide. Now, in a double wide screen, typically we'll have only 1 center chain, but this happens to be a very large screen, so it's got 2 center support chains, 2 chains on either side, so it actually has 6 chains. And we'll see those. Those are installed in Dallas South Side. Those are the biggest screens we've ever built so far, and we'll see a picture of them shortly. But here's 3 double wide S screens. You can see the motor on the roof. That's an older style, but it's nice to see older screens still in service. This is one of those 20-year-old installations I was telling you about. Again, so here's some more large S screens, outside installations. So when we talked about features and benefits for the AquaGuard, they're delivered fully assembled. So here's a 47-foot tall S screen being prepared for shipment. And it comes in one piece, and it's pretty amazing to see. So that's the double wide, double chains Dallas Southside screen. Now we'll talk about the third option for the AquaGuard. We saw the element screens. We also provide it with perforated plate media. Basically, very, very similar machine. The perforated plate screen is built on the same chassis as the element AquaGuard, but basically we replace the elements as the belt media with stainless steel perforated plates. So you get the same reliable AquaGuard performance, but with the benefits of using perforated plate media. You can see the shape of the perforated plates is like a step. Now the reason for that is that step kind of does the same function as the hooks in the element screen, carries solids up out of the channel. We do not have any perforations, you'll notice, on the bends. We do that for strength. The panels are very strong. We don't have any problem maintaining an 8-foot head differential if an engineer would like to do that with a perforated plate screen. Now, why would a customer prefer a perforated plate screen as opposed to an element screen? The perforated plate screens have lower head loss. Because they have lower head loss, you can get more throughput in the same size channel. But they also have better capture rate efficiency, which kind of seems a little bit contradictory. How can you get better capture rate efficiency and lower head loss? Why wouldn't everybody want a perforated plate screen? Again, the features and benefits are very similar. We can get higher throughput up to 150 MGD, where, as before on the element screen, we said 100. Again, that's due to the lower head loss. Here we can see some of the elements that make up the perf screen. It's very similar to the element screen. The only thing is, main difference is that spray washes are mandatory for the perforated plate screen. On the element screen, spray washes are optional. And the brush that you saw on the element screen, the perforated plate screen also has a brush, but it's a different style. It's a full round brush, and it also has a directly driven motor. So it turns at a much higher rate of speed than on the element screen. And that's important because we need that extra oomph to get those panels clean. So you're always going to see 2 drive motors on a perf screen. Here's the main drive motor, here's the brush motor with that direct drive. And spray bars, 2 spray bars. Can't see the second one on there, but those are also mandatory. Here's a look at installation. 2 perforated plate screens feeding a 1 helix press, and you can see how the perf screen, because of the higher rate of capture, builds up that really nice mat on the face of the screen. The third and final screen I'm going to talk to you about is the Helisieve screen. So it's also an in-channel screen. It's a different configuration. Typically more narrow channels, only goes up to about 6 MGD is the maximum capacity, and down to only a 1/4 inch opening is the smallest we'll provide. So as opposed to the AquaGuard, where most of the machine is in the channel, in a Helisieve you can see only really the basket is lowered into the channel. So the rest of the machine, the transport tube, and things are all outside of the channel. Angles of inclination, we really offer one, 35 degrees. The whole unit pivots out of the channel for maintenance, and maximum channel depth about 10 feet, whereas we saw AquaGuards can be up to 70 feet tall. This is a different animal completely. This is a nice shot, gets you an idea of what I was talking about. So this is the perforated basket area that goes into the channel. The flow enters from left to right. The solids are captured on that screening basket, and a shaftless spiral then carries the solids up through the transport tube to their discharge in the rear of the machine. Here's a close look at the Helisieve basket with the brushes that are attached to the shaftless spiral That's what keeps that screen clear, so that as solids are removed and conveyed, the screen stays clear to provide fresh screening surface for the influent as it continues to flow. So now that we've looked at the AquaGuard and the Helisieve, I wanted to talk to you guys a little bit about basic channel terminology. So here is a profile look of an AquaGuard screen and the different levels that we like to talk about. I'd prefer to come over and show you on the whiteboard. There's basic information that you have to be sure that you get from your customer when you're talking to him about a new AquaGuard unit as it relates to his channel and his flow rates, etc. So here's a side profile of an AquaGuard installed in the channel with important details that you need to have in order to properly size the unit. So obviously the channel depth. Talk about the discharge height is important. Where does the customer want to drop off the solids that he's removing from the channel? What kind of solids handling equipment does he have? Does he have a wash press or a conveyor? That will dictate the necessary height above the channel that you have to maintain in order to get the solids deposited properly in that equipment. Now, as far as the flow is concerned, obviously the direction of flow from your left to your right, what is the volume of the flow? You want to ask the customer to make sure that he gives you correct information about his average and peak flow. So we're going to design the screen based on the peak flow. Does he have any head loss constraints? In other words, based on the depth of the channel, does he want this upstream water level to stay below a certain height? And he will tell you that. So upstream water level is very important. The downstream water level is critical for the design of the AquaGuard. We need a certain minimum downstream water level in order to keep this differential less than those 36 inches that we talked about earlier in the presentation. So if the downstream water level is not sufficient, then we will install a weir behind the screen in order to bring that downstream water level up to the proper depth. Typically, there will be a piece of equipment behind the screen. In this case, I call a grit chamber. An engineer or a customer will be able to tell you what piece of equipment is determining the downstream water level for the screen. So if that piece of equipment does not maintain a sufficient water level downstream of the screen, then again, we'll recommend the downstream weir in order to bring that level up to a workable level. So that difference between the upstream and the downstream water level is called the differential. That's where the screen works. So as the water level drops and is equivalent to the downstream, then when the trash begins to build up on the screen, it will rise in front of the screen. It will be a float switch or ultrasonic sensor will activate the cleaning cycle, and the water level will go back down. Two final things that are very important, again, is the installation angle. We talked about standard installation angles of 60, 75, and 85 degrees. So this is where it's measured. And the bottom of the channel, you can see the screen here is sitting in a recess. The recess is very important. It allows the customer to use the full face of the screen without any loss of head. In other words, that the toe of the screen is a dead zone where no water passes through. So if the bottom of the channel is flat and that dead zone is exposed to the flow, all you're doing is adding head loss, losing that operational depth that you have at the top. So we like to install the screen in that recess so that you can use the full channel depth. The recess for an MN screen is 3.5 inches, but you can see for a perforated plate screen it's 9 inches. That's a lot of potential head loss. In other words, potential area of operation that you would lose if you installed it on a flat channel instead. But again, when you're talking to a customer, there are certain pieces of information that you need to have. So you want to talk to him about flow rate. And we always design the screens to the peak flow. Okay? That is the maximum amount of water that's ever entering the plant at one time. And that's what we design for. Oftentimes, customer says, well, I don't know. I know what the average is. So if the customer can give you the average flow, a loose rule of thumb is that the peak flow is about 2.5 to 3 times the average, and that's just a rule of thumb. So if you cannot get the customer to tell you what the peak flow is, you can use that to calculate it roughly. What are his head loss requirements? So that has to do with the depth of the channel that he's working with. Very often the customer will tell you, you know what, we want to maintain 1 foot of freeboard at all times in the channel. So the maximum head loss that you're allowed is 14 inches. So he says, okay. So if he tells you that's all you have to work with, then you want to know that. The footprint, where is he going to install it? Is it going to be installed indoors? Are there any space height limitations, etc.? And what are his screening needs? In other words, what size opening is he looking for? What is he trying to accomplish? Channel dimensions, very important, obviously, the width and depth of the channel. Does he need washing and compacting and dewatering as well? And, of course, the downstream water level that we talked about a little while ago, that hopefully he can provide that to you. If he can't, if he says, you know what, I really don't know, then we will make assumptions. They say, what is the downstream water level that we would like to have? And then we will give that information to the customer. Since our calculations are based on downstream water level of X. And if you can't provide that depth, then we can recommend a weir. And if he has information about solids loading, that's always nice to know. Is this a very lightly loaded application, or is it a very heavily loaded application? That might determine which machine we recommend for him. So once you get that information from the customer, and you know what angle he would like to install, what the flow rates are, the water level numbers, information about his solids loading, then we will provide him with a proposal for the best possible suited screen for his application. We'll recommend the channel dimensions for new installations, give him all of the head loss information, and if a downstream weir is required, we will then also make that recommendation. We always quote head loss in terms of clean water. If a customer wants to know, well, what is going to be the head loss for domestic wastewater, and we can also use a D-rated factor to give him that information as well. But head loss, as we talked about earlier about what are the differences between the element screen and the perforated plate screen, I told you the perforated plate screen has lower head loss. How does that accomplished? Percent open area, or how much water can pass through a certain opening, really affects head loss directly. So the reason why the perforated plate screen has lower head loss, it has a lot more open area. See, on the right-hand side is a typical element screen with a 6 millimeter opening, and you can't see through it. So the amount of open area on the right, on the example on the right, is about 35. On the left-hand side with the perforated plate screen, there's a 48% open area, and you can see right through it. So you can see why the head loss would be lower and more flow could pass through those openings. But remember, on the perforated plate openings, those are perfectly defined round holes, so the capture rate's higher as well. So here's an idea of the relationship between head loss and open area. So as the open area increases, the head loss decreases for a particular flow rate. Again, the smaller the defined open area, the higher the capture rate. The higher the capture rate, the more solids will be removed. But even equally important to that is the efficiency of the cleaning system. So as the cleaning system that we looked at with the brushes and the spray bars, if that's working efficiently, then you're maintaining that open area, maintaining the high screening capture rate, and everything will be hunky-dory. But as that cleaning system becomes less efficient, obviously then your open area, that large open area that you would provide the customer, becomes reduced, head loss goes up, you get higher velocities going through the screen, and when that happens, you run the risk of then pushing those solids through the screen that you just captured, which would be bad. So again, here's a look at why the perforated plate screen then has that better capture rate efficiency. The Element AquaGuard really has a slotted opening on the 6 millimeter screen. That slot is about 6 millimeters by 17, so you get 102 square millimeters of open area. On a perforated plate screen, a 6 millimeter screen has a 6 millimeter circumference, a 6 millimeter hole in both directions. So the opening is a little bit more than 28 millimeters square. So that's how you get that higher capture rate efficiency. Now I'm going to tell you a little bit about the new AquaGuard Ultra Clean. As we've talked about all morning, the AquaGuard's been in, Parkson's been selling AquaGuard since the late 70s. It's been a very, very good product for us. Everything has its limitations. So a lot of it, we've been getting feedback from a lot of our customers. They tell us, hey, you know, we'd like to be able to reduce the maintenance on the AquaGuard. We'd like to have a brush that's easier to clean, that keeps the screen cleaner longer. So we listened to those types of comments, and about a year and a half ago started what we called the AquaGuard Redevelopment Program to redesign the screen with the operator in mind. So we wanted to make it more maintenance friendly, get better access to the screen. We wanted to improve the performance, increase the capture rate efficiency, and reduce downtime as it related to the brush. So we went to the lab, and we made certain improvements to the screen. We changed how the machine is accessed. We changed how the brush functions, and went out to do a real-world test and had great success, which the new AquaGuard has 50% better capture rate efficiency as compared to the current design today. This live test that we did at the Sunrise Wastewater Treatment Plant, we did a side-by-side comparison with one new Ultra Clean and one standard AquaGuard side-by-side. We changed one machine, and we would be hearing one of the mechanics telling us what he's talking about is that he's very happy because the new Ultra Clean is easier to maintain, and he gets half as many rags out of this pump that he's working on. He's telling us that he used to get 2 buckets, now he only gets 1 bucket. And that was with only one of the screens modified. So once we get the second screen modified at his plant, plan to cut that amount of rags in half again. So he's very, very happy. Now, what makes an AquaGuard Ultra Clean different? Well, visually, it's very different. So here's the look inside the rear of the standard AquaGuard at the Sunrise Wastewater Treatment Plant. And here's a look inside the back of the Ultra Clean. So visually, it's very impressive. You know, which screen would you rather have in your plant? Operationally as well, here's a look at the Sunrise standard unit working. You can see, barely see the brush back there. It's all matted up, and it's frankly very ineffective. It's doing very little cleaning of the belt at this point. It should have been cleaned and changed, but unfortunately that's what happens in the real world. That's customers don't always do the maintenance that they're supposed to do. So let's look at the Ultra Clean. It's much different. You can actually see the brush back there. It's clean, it's effective, Because of the location of the brush, where we've changed the belt path slightly, it really encourages the solids to drop off sooner. So even before the solids reach the brush, they're almost all dropped off. And that really allows us to keep the belt extra clean, which increases the capture rate efficiency of the new unit. One very important feature of the new Ultra Clean is the brush itself. Instead of a simple 4-bristle brush, the way the current AquaGuard brush is, we've added rubber paddles to the brush. That effectively increases the diameter of the shaft, reduces the amount of ragging of the brush that occurs. The solids can't wrap up the way they are in the pictures on the right. The new brush, that doesn't happen to it because those long stringy solids don't have a chance to wrap up the brush because of those paddles. Also, we've increased the speed. The AquaGuard Ultra Clean is going to have a directly driven brush just like the perforated plate screen. So that also increases the cleaning and effectiveness of the brush. The second really important change is we changed the belt path and the placement of the brush. So in a standard AquaGuard unit, the brush is kind of here in this area, and the solids tend to drop off more in the rear of the machine. So in the new Ultra Clean, we move the brush more into the center of the discharge, and the solids drop off closer to the back of the machine. So they're landing in the chute where they're supposed to be. That's why it helps keep the interior of the screen clean as well, and also helps to increase the capture rate efficiency. So this is a demonstration of that. You can see in the standard unit, solids are piling up all the way through the transition chute all the way to the back of the machine. But in the Ultra Clean unit, you can see where the solids are landing really in the discharge chute. That debris field is lowered. It's moved more to the back of the machine, keeps the inside of the machine clear, makes sure those solids are all getting into the transportation equipment where they're supposed to be. The Ultra Clean screen also will have 2 spray bars, which have been optimally optimized. We have them now. We've changed the orientation of the way we spray to really get those solids off the belt. At sunrise, those sprays are being used under 10 psi. So we're trying to reduce the amount of water that we're using as well. So here's a look at in yellow is the path. You can see where those spray bars are located. So here's a look one more time. The first video I showed you had the spray bars on at 25 psi. Here they're running at 5 psi. Much less water, same effect. Now the last thing I want to show you then is we've also changed the look of the machine. So the new AquaGuard Ultra Clean is going to get a distinctly modern look. Here on the left-hand side, you can see a standard AquaGuard, although that's a 60-degree unit. On the right-hand side, 75 degrees. But now you can see the rounded edges. The head's a little bit deeper because of that belt path change. But accessibility was important. So here on the front cover of the new AquaGuard is going to lift up in this way. Call it like a car hood type thing. And it's also going to have doors for access to the front and rear of the machine. So finally, very quickly, we'll look at the dewatering equipment. We've got a couple of 2 different presses. The first one I'm going to talk to you about is the high press. This is a hydraulic ram press. This is not a washer. It's a compactor. So solids are deposited into the hopper here in this area, and then the high press has a hydraulic ram which merely pushes those solids out and compacts them into that discharge pipe. Again here, shows the 3 aqua guards feeding a conveyor, feeding the high press, and you can see here the hydraulic equipment, the hydraulic ram is here, just pushes those solids out into the discharge pipe where they're compacted and dewatered. Now, the Aqua wash press is a little different. It has a shafted screw, and it's also a washer. So this is a washer compactor. Has a hopper. Solids are deposited in the hopper. They're moved through the machine into the washing zone by the shafted screw. Then when the solids are washed, then they're pushed up into the discharge pipe where they're further compacted and dewatered. So there's a look inside the hopper. That shafted spiral has a brush, just like the Helisieve that you saw earlier. On the upper right, you can get a look at the outside of the wash barrel. That is where we're deluging the solids with a lot of water to get that washing. And a look at the sealing and drive system. It has packing gland to keep water in the machine and out of the gear motor. So here's just a look at the Aqua wash press on the right-hand side there, installed under an Aqua guard. So I've got a quick demonstration of the Aqua wash press. Really, this is kind of a destructive video just to show the relative strength of the machine. So we're going to put it on a steady diet of rocks and wood and bricks and all kinds of good stuff. Obviously, these are not typical solids that you would see in a wastewater application, but this is merely a demonstration video to show the relative strength of the machine. Now, this is the 8-inch machine, so this is the baby one, which is pretty cool. So we have 8-inch, 10, 12, and 17-inch models. So this is the smallest one. There goes a bag of rocks, obviously. Again, it's not typical wastewater solids, but pretty fun. Now this is the 17-inch version. Same principle of operation, just a lot bigger. There's your typical house plants going in. Crazy mad scientist. Toilet seats. That's a 12 by 12 paver. Big. And a 6 by 6 post. No problem. This was just an afterthought with the beach chair in there. They're usually only good for one trip to the beach anyway. You come bring them home and they don't work anymore, so you feed it to the Aqua wash press. Just really quick, the last piece of equipment I wanted to talk to you about is the helix press. So when you have a complete headwork screening system, like we talked about the Helisieve, that it screens, conveys, and compacts. The helix press conveys, compacts, and dewaters in one step. So here they're being fed by the screens. The helix press has a shaftless spiral, conveys the solids to the end of the machine, similar to a Helisieve, where there is a compaction and drying zone. And then the helix press also has a back pressure device that further dewaters the solids before they're released. This is just an illustration where you can barely see that there's a helix press being fed by 2 rotary drum screens. And that's it.
Can you custom design your screens to fit within pre-existing channels?
That's a really good question. Yeah, absolutely. All of our screens are custom designed to customer specifications. So if a customer has an existing channel, we will adapt one of our standard widths to the existing channel and fit it as closely as possible, and then make up any difference with baffles and sealing equipment.
Okay, for an existing AquaGuard, can you rebuild the existing head with ultra clean head? And what would be the main steps to do so?
Oh, definitely. Obviously, I didn't mention. We only talked about new units for ultra clean, but absolutely, we have a retrofit program, rebuild program for our existing AquaGuards in the field to retrofit them to the new ultra clean standard. And basically, the short answer is that we will remove the existing head and replace it with a brand new ultra clean head with the brush and the sprays and the covers.